So we stopped here, right? So we were talking about identification. Can I please close the door? Okay. So let's go back to the example. And all I am trying to think of here is the labor supply of married working women. Yeah. So it's a female labor force participation in some way who have already participated in the labor market and they have started working. So first equation is their supply equation where I claim that hours depend on wage, then the education, age, and then the number of kids less than age 6, and then the family income. The supply equation is, I'm going to claim, it is being identified because if you look at the demand equation, it does not, it includes the two variable, experience and experience squared, which is not there in the supply equation, right? So therefore, the supply equation is being identified. If you now look at the demand equation, you observe that the kids less than age 6 or the number of kids less than age 6 and the family income is not being included in the wage offer or the demand equation, right? So that equation also being identified because I have couple of variables which is either being included in the demand but not in the supply and vice versa, right? So given this, I then want to think of that suppose the rank condition, that is the condition, the exogenous variable excluded from the equation are included in the other equation, I can test it by using something like a reduced form equation. So recall the reduced form would be what? I have the log of the wage. Now it would depend on education, age, number of kids less than 6, family income, experience and experience square. So because that's my equilibrium condition, I substitute the demand equation in the supply or the equilibrium I find out by assuming that the supply is equal to demand. Yeah. I do some manipulation and I get the reduced form equation. Given if I run a regression on the reduced form equation, I'm going to claim that the labor supply function is going to be identified if and only if the coefficient associated with the excluded variable in the original equation is not going to, in the original equation is not going to be equal to 0. So let's go back. Note, in the original equation, experience and experience square was not being included. If I now look at my reduced form equation, then what does it mean? I want to reject the null that pi to 5, which is the coefficient associated with experience, and pi to 6, which is associated with the square of experience, is not going to be equal to 0. What does it boil down to? If I now think of my structural equation, then it boils down to the case that the coefficient from the wage offer equation, which is my beta 22 and beta 23 associated with experience and experience square, is not going to be equal to 0. So in one way, testing for pi to 5, which is equal to pi to 6, which is equal to 0, is exactly equivalent to test for whether beta 22 is equal to 0 and beta 23 is equal to 0. Note, as I have two restrictions here, I am not going to use a T, but I am going to use an F test because I have more than one restriction in this particular case associated with pi to 5, pi to 6 or beta 22 and beta 23. Yeah, fine. So given this, I can then think of estimation can be done what we call as by a system known as or by a method which is known as two-stage least squares. What is the two-stage least squares? The way I want to think of two-stage least square, it is nothing but running least square in two steps. In first step, I regress the endogenous variable on the set of instrument or on every variable. Okay, I get the predicted value of that endogenous variable. Step 1. Step 2 or stage 2, instead of using the actual variable, I use the predicted variable or the predicted value of that variable from my first stage, and I then run a least square. And hence, I am running two least squares, which gives me nothing but the 2SLS. Clear? Fine. Note, so in a first stage, each endogenous variable is regressed on the full list of exogenous variable, right? Reduced form regression. I get the fitted value. I replace the actual by the fitted and run the second stage regression. That's the way I think of. So in a second stage, the system equation are estimated by OLS, but with the endogenous regressor being replaced by their predicted value. That's what I exactly said. Note, if the equations are not identified, I'm going to only estimate whatever is being identified. If certain additional conditions hold, then I can use something like the other efficient methods, which is nothing but, for example, three-stage least squares. So you can use even limited information maximum likelihood or full information maximum likelihood depending on certain condition. But to be very clear or very basic way, we want to think of first as the two-stage least squares, and two-stage least squares is not a bad method in case of this kind of regression. Yeah, fine. So remedy, recall, I have in a matrix notation y is equal to x beta plus u, and I have the set of instrument which is nothing but z. Clear? So I want to think of that, suppose I want to think of that there is only one endogenous variable which is z, and I want to have the moment condition as expected value of z and epsilon, or my error term, to be equal to 0. In a matrix notation, that's nothing but z prime y minus x beta is equal to 0. Recall, y minus x beta is nothing but your u. U is equal to y minus x beta. I can then think of this y minus x beta is nothing but u. So z transpose u is going to be equal to 0. And that's my moment condition. Right? Clear? So given this, I then want to think of my beta hat IV is nothing but going to be equal to z transpose x inverse z transpose y. So note, where my original beta hat OLS was equal to x transpose x inverse x transpose y, all the x's are being replaced by the z. Clear? Z transpose x inverse Z transpose y. So if we have a set of variables Z, so I have the matrix of instrument which then satisfies the moment condition Z transpose y minus x beta, which is nothing but Z transpose u. We need to use the two-stage least squares. Yeah, fine. So more in terms of step 1, I regress each of the variable in the X matrix on Z to obtain a X hat. So note, my X hat would be nothing but Z, Z transpose Z inverse, Z transpose Y, which is nothing but I am going to make something like a projection matrix. Projection of what? Of X on Z, which is my PZ. So PZ is nothing but equal to this notation Z, Z transpose Z inverse Z transpose, and I have the X. So that is nothing but my PZ times X. In the next stage, regress Y on X hat to obtain beta hat. So beta hat 2SLS would be nothing but the predicted value, which is X hat. Replace your X transpose X inverse by X hat transpose X hat, right? inverse. Wherever X transpose Y was there, I replace that by X hat transpose. I can think of my X hat is nothing but Pz X. I substitute the value Pz X inverse, then X transpose Pz Y, which is nothing but beta hat IV. Right? Clear? So recall X transpose Pz X inverse should be equal to what? X inverse, Pz inverse, X transpose inverse. Inverse of the transpose is the same thing, right? Clear? So basically this is like ABC inverse, which would be nothing but C inverse, B inverse, A inverse, right? So I can think of this as written as X inverse, Pz inverse, X transpose inverse. X transpose inverse and X inverse is the same thing, right? So I then have X inverse, Pz inverse, X transpose inverse, even if you think of X transpose Pzy. Recall X transpose inverse and X transpose is an identity matrix. So I end up with X inverse, Pz inverse, Pzy, which is nothing but my beta hat IV. Right? Clear? Sorry, matrix is in my blood. Clear? And that's why it is. Clear? Right? Exposition? Very simple proof. Very easy. Just remember two properties of inversion. ABC inverse is equal to C inverse, B inverse, A inverse. Inverse of the transpose of a matrix is nothing but equal to the inverse of the matrix. That's it. It proves. Good. What is the intuition? So the intuition is quite important here. So note what we are trying to do. First, we want to find out the impact of the exogenous or the instrument on X, Z on X, right? My first stage regression. Second, I want to find out Z on Y to calculate the effect of X on Y, but it is only from the exogenous variation, because I am using what? I am using the fitted value of X when I run the regression of X on Z. So if you think of that Byx is the coefficient associated with the endogenous variable X, it has two components. What are the two components? The first component, so if you look at this component, this is the impact of X on Z, and this is the impact on the Z on Y. Combining the two, I get the impact of del Y del X. Note, del Z del X can be written as 1 over del X del Z, right? So that is nothing but impact of Z on X, the first part. The second one, straightforward, del Y del Z, which is like the impact on Z on Y. However, I am claiming this, the ratio, as nothing but the impact of Y on X, simply because the variation is coming from the variable Z, which is nothing but the exogenous or the set of instrument. Yeah, that's the logic over here. So del X del Z, impact of unit change in Z on X. Similarly, del Y del Z is nothing but impact of unit change in Z on Y, right? There is nothing rocket science here. So given this, I then want to think of, suppose I want to determine the example of wage on schooling or number of years of education, yeah, which is a very good example, I believe, where Z is the instrument. And what is Z? Z is nothing but proximity to the nearest college as instrument. So it is likely to be associated with schooling, unrelated to ability, which would be captured in the disturbance term as an omitted variable. So note, 1 unit change in Z, in X, I can think of that is nothing but del X del Z, which is beta XZ, Z prime Z inverse Z transpose X. Remember my projection matrix? The first part and then the X. If beta xz is equal to, suppose equal to 0.3, so one more unit of Z leads to 0.3 years of schooling. I can claim that. Given this, I then want to think of 1 unit change in Z, how much does it cost in Y? Because that's my interest over here, which is beta YZ, which is Z transpose Z inverse Z transpose Y. And suppose now beta YZ turns out to be 100. Clear? So 1 more unit of Z through X increases the wage by rupees 100 per hour. That's what I am claiming. Using the effects of instrument, what would be the impact then? Byx. Recall Byx is nothing but del y del x, which can be written as del y del z times del z del x, which can be written as del y del z divided by del x z. Del y del z is equal to 100. Del x del z is equal to 0.3. So it is 100 divided by 0.3, which is 333.33. Right? Not 100. So Z impacts wage only through education. We can then infer 1 unit of schooling increases wage by 333.33 rupees per hour instead of 100 rupees per hour. Clear? Fine. So given this, I can then go ahead more in terms of the intuition. Recall beta hat IV is nothing but beta YZ divided by beta XZ. Beta YZ is Z transpose Z inverse Z transpose Y. Beta XZ is Z transpose Z inverse Z transpose X. They cancel each other provided they are not singular matrices. So given that, I get Z Y divided by Z X. Z transpose X, which is my Z transpose X inverse Z transpose Y. Clear? Recall the first part, which is the denominator, which is Z transpose X, comes in forward. So Z transpose X inverse Z transpose Y. Right? Recall this is not scalar, this is matrices. Right? Clear? So empirical evidence that IV estimation actually is bad if you have weak instrument. So if you have really weak instrument, it is better to use IV rather than OLS. It is better to use OLS rather than IV. I can even think of that I can have something like whether the instruments are good by running something like an F statistics. I calculate the F statistics from my first stage regression, which I can test whether the instruments are good or not. And in general, the rule of thumb, if F greater than 10, instruments add explanatory power to the first stage model and is not weak. And for multiple instrument, this is not valid, but I can apply something like the same F statistics, but with a different critical value of stock and Yogo. Clear? So that's basically all the thing that we need in terms of the F statistics. Given this, so note I have two competing models, right? The two competing models are OLS and IV. Recall Haussmann, a name familiar, got the Nobel Prize. Haussmann is very good. What Haussmann does, Haussmann is nothing like a fixed effect random effect test. That's what most of the people visualize Haussmann. Haussmann is a specification test. Any specification can be tested by Haussmann. Okay. So here, what are the specification? My null is OLS is valid. Alternative is IV is valid. Haussmann. Clear? So note under the null, OLS is not only consistent but as well as the efficient if the null is valid. Under the alternative, OLS is not only efficient, forget efficiency, it loses the consistency, right? Under the alternative then, IV is consistent. Clear? So I can do an Haussmann test between the OLS and IV to show whether the Haussmann test prefers the IV, instrumental variable regression, or the OLS. Is it clear? So you can do a specification test following Haussmann between IV and OLS, where your null is OLS, alternative is IV, and it is nothing but again a what I call as a specification test. Recall in panel, you assume random effect is your null and then fixed effect is the alternative. Here it is OLS versus the IV, and all we want here the consistency. Recall the consistency is different from unbiasedness. Unbiasedness tells you expected value of beta hat should be exactly equal to beta, whereas consistency required is nothing but prelim of beta hat should be equal to beta. Clear? Fine. So that's the difference between the consistency and the unbiasedness. Recall an unbiased estimator is a consistent estimator, but the vice versa is not valid. Clear? Fine. Okay. Shall I move? Yes, please. Yeah. So F stage is nothing but my, as I said, any F restricted versus unrestricted. R square U is, you can think of that is nothing but the R square from my unrestricted model. R square R is the from my restricted model, and I have the number of restriction which is R divided by 1 minus R square U divided by n minus k. The degrees of freedom under the unrestricted model should be distributed with FR n minus k. You can also use the RSS version of it or the residual sum of square version of it, where it would be the numerator would be restricted residual sum of square minus unrestricted residual sum of square divided by R, the number of restriction, divided by unrestricted residual sum of square divided by n minus k, and you should get exactly the same result. Okay, clear? So this is none of the first step. Yes. 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 Clear? I'll then come to what I claim as the sample selection problem. What is the sample selection, right? And to think of that I have something like a random sample which I have collected from the population. However, there could be several things that could hinder my progress of getting a random sample. First, samples may not be random and truncated by the economic variables. A classic example, as I said, I'm going to participate in the labor market if and only if the offered wage is higher than or equal to my reservation wage. In that case only, I observe how many hours the individual has worked along with the wage they receive. If they don't work, then I don't observe their number of hours of working. Clear? Fine. So given this, I have two equations. What are the two equations? I am to find out that the impact of wage on number of hours, x1 on y1. However, I observe y1 given by my selection equation. What is my selection equation? I participated, takes the value of 1. I did not participate, take the value of 0, right? So the way I want to think of that, we assume that we always observe x regardless of the value of y2. Recall y2 is equal to 1. When y2 is equal to 1, only then we observe the y1. So I don't observe number of working hours if the person did not participate in the labor market. Clear? Fine. Okay. So that's the way I want to think about it. The way I then want to modify that x actually contains all variable in the vector x1 plus some more variable. Clear? Okay. And why? Because this is nothing but known as identification through exclusion restriction. What is the exclusion over here? X contains something more than x1. So if you think of x1 does not contain something which is being contained in x. So I am excluding something from x in terms of x1, and hence I want to call that, as I am excluding them, I want to call it as exclusion restriction. Unless what is the, if I don't do it, what is the problem? The problem is the identification has to be done through one parameter, which will come in a second, which I'm going to call as inverse Mills ratio. Okay, and I'm going to introduce you the concept of inverse Mills ratio. Note, I'm going to think of that presence of selection bias. What are the assumptions? X and Y2 are always observed, right? Y2 is in,
What is Y2?
Y2 is in terms of whether you have participated in the labor market. A binary indicator takes the value of Y2 is equal to 1 if you participated, 0 if I don't. So for everybody I observe Y2. For everybody I observe X. But I observe Y one only for those guys where you have participated in the labor market. So number of hours worked only being observed for those guys who has participated in the labor market. That means I observe Y1 only for those guys when Y2 takes the value of 1. So think of that's like a success of participating in the labor market. Next assumption, I have two error terms. U1 first equation, V2 second equation, and I claim they are independent of X with zero mean. So X is exogenous variable, strictly exogenous variable. And then I assume some distributional assumption. V2 is a standard normal, which is distributed as mean 0 and 1. And then expected value of U1 given V2 is nothing but gamma to V2. So that allows that correlation between the residual of the two equations. So I'm not assuming covariance of U1 and V2 is going to be equal to 0, right? And here I claim they are distributed as a bivariate normal, okay, where the covariance term in the bivariate variance covariance matrix term would represent the correlation or the covariance between U1 and V. Okay. Yes.
You're talking about the selection bias of variable or the selection bias of units of sample.
I'm talking about the selection bias of the estimated equation. So it is like a selection bias of the sample. So I observe something and I don't observe something. And then the next stage is I collected a sample of 1,000 people, right? For whom 400 people I observe number of working hours. Why? Because they have participated. But I observe the other one because I know whether they have participated or they are not participated. So for Y2, I have the distribution of 0.4 and 0.6. Why 0.4? Because something like 40% has participated. 400 people, I told you, right? Yeah?
So whenever they include a dummy variable, is
Yeah.
there any selection bias?
Not always, not always. But in this case, the sample gets selected or truncated. Sample gets truncated of what? Of the labor supply equation, not about the participation equation. You see the participation available for thousands of the individual. Participated, yes or no. Then next stage. If they participated, then only I observe their working hours as well as their wage. I do not observe their wage even if they don't participate. But I know their other characteristics. I know their age, I know their experience, I know their household status, everything else. I know. Whether they are married or not, I even know that. But I don't know the true crucial variable, which is the number of hours worked and the wage being offered. Clear? Fine.
So,
Yeah.
sorry to interrupt you.
No, no, that's fine.
So you here you mentioned about like U1 and V2.
Yeah.
They are the error term of two separate equations.
Yes. So let me go back. So that's the primary equation. Number of hours depend on the wage.
Yeah.
Error is U1. Whether, yeah.
Here Y1 is the wage
Here, Y1 is the number of hours worked,
hours work, and X1 is
wage,
okay, which are labor supply.
right?
Then in second is Y2 is
Whether I have participated in the labor market or
participant.
not, which depends on certain characteristics, which is X, age, experience, number of dependent at the household level, family income, it could be anything, right? Clear? And that error is V2. So then I have two errors, U1 and V2. Given this, I assume that U1 and V2 is independent of X. And I also assume that the correlation between U1 and V2 is not equal to 0.
X are the control variable.
X are the control variable for my second stage.
Age, gender, etc.
Absolutely is my second stage, where I observe whether you have participated in the labor market or not. Clear? So X is something like the grandfather, and X1 is the son. So I assume that the grandfather or the error associated with my grandfather equation is also, or father equation, is also correlated with the son's equation. Why? Because of genetic ability. Did I explain?
Yes. Third, third you have explained.
Yeah.
Third assumption is
Third assumption is just nothing but a distributional assumption. I assume that the error associated with my selection equation is a standard normal. Mean 0, variance 1. Clear? And then the correlation, but recall variance of V2 is equal to 1. Why? Because I have assumed V2 is a standard normal. So therefore, the gamma 2 is nothing but the covariance between U1 and V2. Nothing more than that. Okay? Clear? So sample selection bias actually can be viewed as a special case of endogeneity bias. Okay? And because the selection process generates endogeneity in the selected subsample. Clear? So it is nothing but can be viewed as an endogeneity. Why? Because the selection creates something like an endogeneity in the labor supply equation, okay, which is my selected sample. Yes.
so you were saying that we have a sample of 1,000
We have a sample of 1,000.
and how many people participate in the labor market? How many people
Did not
participate in
participate.
the labor market? If it is a random sample,
Yes.
so we don't know. It could be 400.
Whatever it is.
participated, it is.
Yes.
So
When I estimate only without taking into account who has participated, I estimate a equation with 400 observation.
which was equation 1?
Which is my labor supply equation. But actually, you have 1,000 people in the sample.
Yeah, but even in equation 1, the independent variable which is binary.
No,
It's
in
not
equation
binary.
1, it is like,
Primary equation.
yeah, which is like wage.
Wage rate, yes.
So that's a continuous variable, right? It could have a binary, doesn't matter.
But in equation 2,
Yeah.
next equation which we
The
have,
dependent variable is a binary.
and that also we have 1,000 observations.
That we have 1,000 observation. But what happens if y2 is equal to 0, which is the participation equation, what you will observe as y1 is dot. Because you cannot measure the number of working hours of those guys who did not participate in the labor market.
That will be 0, or we don't have
Dot.
It's a missing value.
It's a missing value.
Why it is a missing value?
Because I don't observe them. If you did not come to IIT Indore for this workshop, I don't know you or your questions. But you exist in the universe.
But for other variables are there. Like
Other variables, age, experience, everything is there. I don't care. Because that would determine whether I would participate in the labor market or not.
because the dependent is ours.
Yes, the primary equation dependent is ours, right? Clear? So something like, you do agriculture, right? So think of the agriculture standpoint. Whether I would use every land available at my disposal for rice cultivation or not can depend on certain factor. So what I observe is nothing but acres of land that is being used for rice cultivation. But that does not mean that you didn't have more land. It could be barren land. So you have 1,000 lands at your disposal, but you used only 400 acres of them. Why didn't you use the 600 acres? Because you thought that the rainfall was not good enough for sowing the seed of the rice. A sample selection. So what you then observe, the rice grown given where you have the rice seed being sowed. You got it? Same thing here. I observe those guys working hours who have participated in the labor market. Why did they participate in the labor market? Simple reason. Why did you accept the IIT Indore job? Because you have a reservation wage. And IIT Indore has offered you a salary. You did some calculation and you think that if you accept the job, the offered wage, right, is definitely higher than your reservation wage. Hence, your net utility from accepting IIT Indore job in a cardinal terms is definitely positive. Hence, you came to IIT Indore, right? And now when you came to IIT Indore, it's a different issue. Clear? I participate in the labor market. You have accepted the job, given your characteristics. What that determines whether you will accept IIT Indore offer or not. I have heard some external came last time in your interview and said no, none of the candidate is suitable for hiring, right? So nobody participated in IIT Indore as faculty in HSS or in economics. That's an example, right? Clear? Fine. Shall we proceed now? Okay. So given this, selection bias when gamma 2 is not equal to 0. Think of it. I'm trying to find out the values of expected value of y1 conditional on x and v2, right? Which is nothing but x1 beta 1, my deterministic part of the first equation, primary equation, clear? And then expected value of u1, but that is now being conditional on what? The original huge set of explanatory variable, age, experience, number of kids, family income, everything, and the error term, which is the V2. Clear? And then I claim that's nothing but x1 beta 1 plus expected value of u1 conditional on V2, law of iterated expectation, x goes away. That's nothing but equal to x1 beta 1 plus gamma 1 V2. Recall the assumption. Expected value, look at assumption D. Expected value of U1 conditional on V2 is gamma 2 V2, right? I just substitute that over there. V2 is not observed. 6 is not directly usable in applied work. And what I do is basically I get an expression of the expected value of y1 conditional on observables, which is like age, experience, number of kids, family income of my participation equation, and the actual selection y2 by using again the law of iterated expectation. And what it turns out to be that at the last expression, I get something like x1 beta 1 plus gamma 1, and then h could be any function which depends on x and v2, and that could be even a nonlinear function. Clear? Fine. Where hx2 is the expected value of v2 given x and y2. Because recall, that's what I have, gamma 1 v2, right? I need to find out the expected value of y1 conditional on x and y2 now, and which turns out to be x1 beta 1 plus gamma 1. Look at that, gamma 1 plus expected value of v2, where I can claim expected value of v2 is nothing but hx and y2. That's what I do. Okay, clear? So given this, what I then want to do? I have this expression given the sample selection equation y2 is equal to 1, which is nothing but, what does it mean? Expected value of v2 conditional on x, and now the participation y2 is equal to 1, which would be nothing but x2 is equal to v2 conditional on v2 greater than minus x delta 2. Is it too tough? I don't think it is that tough actually, but anyway, it could be. So recall your equation, right? Your equation was y2 is equal to x delta 2 plus v2. Isn't it? That's what we wrote. Note y2, when y2 is equal to 1, then 1 is x delta 2 plus v2. Isn't it? And when it is equal to 0, then that's equal to x delta 2 plus v2. Right? Note what I have here. v2 greater than equal to minus x delta 2 is exactly following from here. Okay? That's nothing more than that. And then given this, what I then can think of, recall what did we assume as v2? v2 is a standard normal, right? So what is the probability of observing v2 when v2 exceeds a certain threshold? What is the threshold? The threshold is nothing but minus x delta 2. I can think of what is the probability of expected value of z, observing that, when z greater than a critical value, which is nothing but c, where z is a standard normal, which is nothing but the density divided by 1 minus cumulative density, right, which is phi c divided by 1 minus phi c. In terms of minus delta 2, then I replace the critical c by minus x delta 2, and I get phi minus x delta 2, 1 minus capital phi minus x delta 2. This I can write it as phi x delta 2 divided by capital phi x delta 2. Why? Because phi is a symmetric distribution. So 1 minus capital phi minus x delta 2 must be equal to capital phi x delta 2, which is nothing but I call as lambda x delta 2. This lambda is nothing but inverse means ratio. So what I do in terms of in practice, I run the second stage regression. I get the prediction of the second stage regression. I get the density function. I get the distribution function. I take the ratio of the two and I include that ratio as an added explanatory variable in my first equation. And hence I correct it for sample selection as well as endogeneity, which is arising because of the truncated sample. Clear? And that's what I do, that I run the regression of y on x plus that inverse means ratio, which is lambda x delta 2. Clear? Fine. So note wage equation. Log of wage depends on education. Clear? Fine. ui is equal to gamma 1 ai plus ei. What is ai? ai is the personal ability. I don't observe the personal ability. I really don't have any measure. So I want to think of personal ability is unobserved and uncorrelated with education in the population. Now I think of that ability, although is an economically interesting part of UI, right? Why? Because I want to think of that ability is uncorrelated with education in the selected sample, but it is not. In the selected sample, also ability and the education can be correlated, right? Fine. If we maintain the assumption that ability and education are uncorrelated in the population, hence there would be no sample selection bias. Therefore, I can simply think of education would be exogenous and OLS is fine. But in reality, that would not be case. Why? Someone I can think of two people, right? one with a low level of education must have then a very high ability. Why? Because he or she otherwise cannot be included in the sample because he is getting some wage. Clear? So low level of education, very high level of ability, hence you observe those guys getting some wage, which depends on education. Realistic example. In contrast, I can think of someone with a high level of education is fairly likely to participate in the labor market, even if he or she has a low level of ability, because education matters in some way. Clear? Bottom line is what? In the sample, I observe average level of ability among those with little education will be higher than the average ability of those guys with a lot of education. Right? Clear? And then education and motivation or ability, whatever way you want to call it, they would be negatively correlated in the sample. Why? Simply because average level of ability with low education, those guys would be higher than the average level of ability for those guys with very high education. So in turn, ability or motivation, ability may drive motivation, right? It can be negatively correlated even though they are uncorrelated in the population. So even if I start with a framework where there is no correlation between ability and education in the sample, I end up with a framework where ability and education turns out to be correlated. Clear? And since ability goes into the residual, we can think of education is negatively correlated with the residual in the selected sample. Clear? Fine. And hence I call it a selectivity bias. What I do, what I can do is a Heckman sample selection model. How does the Heckman sample selection model works? In first stage, I regress or I use all the observation, 1000 observation, right, of Y2 on the set of the explanatory variable. X, remember, age, experience, number of kids in the family, family income. I first use the 1000 observation. I run a probit because it's a 1-0 variable. You can run even a LPM, which is linear probability model, a OLS model. Okay, and then Y2 is the dependent variable, X are the explanatory variable. I calculate the delta hat. As soon as I get the delta hat, I can find out the inverse Mills ratio. In step 2, I use 400 observation, right? Because that is my selected sample where I observe the hours worked and the wage. But I include the estimated inverse Mills ratio as an additional variable. See, the lambda x delta 2. And hence, I solve the problem of sample selection. Clear? Note, I can test whether gamma 1 is significantly different from 0 or not. If gamma 1, if I accept the null, then there is no sample selection problem. But if I reject the null, then it tells me that OLS would give you a biased estimate. Next very important point. Remember, I have two set of explanatory variables, x1 and x. And I want to definitely have something like a variable or additional variable in the x which is not included in x1. Why? Otherwise, I may end up, if x1 is equal to x, I may end up in something like a multicollinearity problem. So I always need something like more variable in x compared to my primary equation. Okay? Right. So note, I can find out the impact. What are the impact? I can find out the effect of changing the variable xk, any one of the explanatory variable, on expected y1 in the population, which is nothing but the coefficient associated with my explanatory variable xk. I can then find out for the same xk, but now I want to find out only for those guys for whom I have observed the hours worked. Clear? So that is like y1 in the population for whom y1 is observed. So that's universe A. B is my selected universe of those guys for which y2 was equal to 1. And that's the marginal effect. That's the way we calculate the marginal effect. Recall if gamma 2 and the delta k would have the same sign, then this partial effect is lower than that on the expected y1 in the population. So sample selection, if you really take into account properly, would give you a marginal effect which is lower than your original marginal effects. Why? The original marginal effects is beta k. Your next marginal effect is beta k minus something. If the minus something would be positive, if it is positive, right, then definitely the number 2 would be lower than number 1, and hence marginal effect for the next case would be something like lower than the first case, provided gamma 2 and delta k are of the same sign. If they are of the opposite sign, the marginal effect would be even higher, right? So it depends on the sign of the gamma 2 and the delta k. Okay, what's the time? 12:54. Okay, I can simply think of, can I extend this model with more complication? Of course I can. Think of y2 is now endogenous in the model. And I have another equation which would govern the sample selectivity, which is nothing but my y3. What do I observe now? What do I assume now? Z and Y3, because note, Y2 is endogenous, but Y3 is now my participation equation, which was my previous case Y2, right? So Y2 gets replaced by Y3, and Y2 turns out to be an endogenous variable. So Y1 depends on Z1 and Y2. Y2 depends on Z and delta 2. Recall, Z1 is a subset of Z because Z includes more variable than your Z1. And then you have the participation equation. Recall, I observe Y and Y2, Y1 and Y2 only when Y3 is equal to 1. Right? So note, how do you think of it? Again, my example. I claim number of hours worked depends on wage, but I think of, or wage depends on number of hours worked. I think of one of them is endogenous, but I observe wage and number of hours for only for those guys who have participated in the labor market. That's my Y3. And then the rest of the assumptions follows, and I now think of my Z2 contains two variables. Why? Simply because I need two identifying restriction. Why? One for my Y3, one for my Y2. So I need one more variable over here for my identifying restriction instead of only one. Okay? Yes.
I didn't get this
Logic?
having three equations.
Okay. Where am I?
There is time.
Sure, sure. So y1, y2, and y3. Yeah. So think of the participation. Participation. Y2, I claim number of hours worked in terms of y1. Number of hours worked depends on wage. But I also claim now wage also depends on number of hours. More hours you work, more wage you get. More wage you get, more hours you work. So there is that simultaneity problem. Y1 gets influenced by Y2. Right? And Y2 gets influenced by something else. And then you have the participation equation. So Y2 is endogenous in my model. Why? Because I don't know whether wage determines hours or hours determine wage.
No, Y2 is the wage or hours?
Anything you can think of. So you can think of Y1 as hours, Y2 as wage, Wage depends on certain variables. And then you have the participation equation. Yes, please.
So the participation equation, if y2 is hours, then like sorry, if y2 is wage, then only after a certain wage is achieved, then I will participate in the market.
Of course.
Right? But it can also be there for hours. Like
Yeah, I observe wage and hours both only for those guys who have participated in the labor market. But I do not know the direction of causality between wage and number of hours. Because wage can influence number of hours. Or on the other hand, number of hours depends on wage. If you give me more incentive, I will work more. If I work more, I earn more. And there is a classic, again, this endogeneity, reverse causality problem. Clear? Fine. But I observe them only if they have participated in the labor market, which is nothing but my Y3. Clear? Okay. So note, these are the model, substitute, we get finally up to this. And then how do I estimate? First, I estimate the participation equation.
y3.
Y3. Recall, in the previous case, I did Y2, right? Now I do Y3. I get the inverse Mills ratio. Then I use selected subsample, right, where I include gamma 1, lambda hat yi3, y2, but I use 2SLS where I use Z and yi3 as my instrument, right? So basically, I extend my first stage OLS in previous case here in terms of 2SLS where I use the instrument list as Z and lambda hat y3. Recall, lambda hat y3 is an instrument for itself. So I just use Z as an instrument for what? For my Y2. Clear? And if we have one exclusion restriction, predicted Y2 will be linearly collinear with Z1 and lambda Y3. And hence we need at least two exclusion restriction as I talked about previously. Clear? Fine? Yes.
Z is used as an instrument for y2.
Z is used as an instrument.
So from that we will get a y2.
You see that in case of 2SLS, everything acts as an instrument for everything. That's what 2SLS does.
So after that is taken as the instrument, then I don't understand what happens after that.
What happens? You get the estimate for your parameters of interest. Yes, you get alpha 1 hat, Z1 hat, gamma 1 hat, everything. Right? Clear? So recall the only difference here in step 2 from the previous case. In the previous case, I used OLS. Here, I use 2SLS. But in both cases, I use lambda hat as an added explanatory variable to take into account the sample selection problem. That's all I do. Okay. I'll come to that later. If you observe, if you have your day 1 GTA file, I hope you have. So this is the file. Oh no, this is what I know. पता नहीं है. This is what I asked them to do. Where is that pen drive here? This one.
No, on the desktop, I think.
On the desktop. Okay. Okay. So go to set 18. Yeah, it would automatically open, hopefully. Okay, so do you have this data with you? So if you have, first thing, there is a data set that is given to you. I think the data set is day1.dta. Okay? I think that's the data set. It must be given to you. isn't it? Should be. And then I have a do file. Day one dot do. Okay. What I want you to do, I want you to run this model, and then you can see that what I am doing, maybe I should select all and then preferences, maybe make it size 20. Can you see this now? Yeah? So what you want is basically, this is the original data from Ulrich. Actually, the data from Rose, the Econometrica paper. Earning regression for females in US contains information on 753 females. However, we observe the wage only for 428. Sample selection. Clear? Participated, I observe. Did not participate, I don't observe. First stage, I just run the regression of wage on education, experience, and experience square. Clear? So that observation would contain 428 people. You see, if I do this regression, yes. We'll give it to you. You got the day one tutorial. Okay. So this is basically 428 observation, sample selection, very clear. Clear? What I do then, I go here, I test whether do something like SSC install. If the internet is not working, then this would not work. I think somebody told internet is not working. Now it is working. Okay. So that's it. So this is basically test whether there is an inverse U-shaped curve between experience and experience square. I can reject the null hypothesis at the 10% level. Indeed, there is something like an inverse U-shape, and the way I want to think about it, this is positive, this is negative. At what years of experience the inverse U is working? At 25.62, right? That also I can figure out. But remember, it suffers from sample selection simply because I have estimated the equation with only 428 observation for whom I observe. Note what I do next. I basically estimate an Heckman equation. Recall, I have, this was my OLS. Wage depends on education, experience, and experience squared. And then I have a selection equation. What does the selection means? My y2 is equal to 1 or not. And it depends on not only these three variables, as well as the exclusion restriction. The family income, then I have the kids age less than 6, kids age higher than 6, and things like that. And I do it two-step. Why two-step? Recall step 1. Y2 is equal to 1, run a probit. Calculate the inverse Mills ratio, right? And then substitute the inverse Mills ratio in your first equation, right? If I do that, it would take a little while. You can see the Mills it comes as, the Mills is not significantly different from 0. But this is again, my L wage equation, exactly the same kind of sign, and the coefficient of course differs. And this is my selection equation. where I know education, experience square matters, but age also matters. That whether if I am getting older, my probability of participating in the labor market is lower. If I have kids less than age 6, my probability of participation in the labor market, being I'm a female, is lower. The family income is a kind of crazy that I expected it to be positive, but it turns out to be negative. Clear? I can also estimate the same model in a simultaneous setup, that this is consistent but not efficient. So if I take away the two step, I would get something like a maximum likelihood, which would be something like more efficient method. Recall what I did previously. I basically call the my model extension, where I claim that one of the variable is endogenous. Here I am claiming education is endogenous. Clear? I can run that model as education as endogenous. So first step, I run this, okay, where I include the mother education, father education, as well as the husband education. Okay. Remember, exactly the same variables are there. Plus, for my identification, I note I need more variables, as I said, and the more variables are mother education, father education, and husband education. Three more variables I included. I can estimate this model as a probit. That's what we do in the sample selection. I get the estimated value, which is my p hat. I calculate the inverse Mills ratio, normal density divided by normal cumulative density. I then do an instrumental variable regression, where education is being instrumented by these guys, right? And then I have the standard equation of L wage and experience square, and then IMR, which is my inverse Mills ratio. Education was my endogenous variable and being instrumented by all these. I'll share the file with you right now, so that you can try it. Which is the drive where I can save it? Huh? Sorry? That's right. Okay, so that would end. We are running out of time by 10-15 minutes. We'll see you on around 2:30. That was the decision, right? I'll come back at 2:30.
Yes, sir.
Hmm?
Should I upload it?
हाँ कर दो ना. So go to my directory. Go to my pen drive. My pen drive, which is